Hey everyone, Professor Lamar here, and welcome to this mini lecture video. Here in this video, we're going to learn about z-scores and understand how we can use them to make sense of a normal distribution. So let's dive in. A z-score tells us how far away a score is from the mean. So here we have a normal distribution, and this is again, think of it as like a standard normal distribution. The average, hypothetically, is a value of 0. And then if we look at this first row here under the curve, SD stands for standard deviation. So we can see if we go 1 standard deviation above the mean, that would be this line here. 2 standard deviations above the mean would be this line here. And then 3 standard deviations would be this line here. Okay. Now, overall, if you think about that empirical rule that we were talking about in our other mini lecture video, 68% of the curve falls within 1 standard deviation above or below the mean. And so if you look here, 34.13% falls within 1 standard deviation below the mean, and 34.13% falls 1 standard deviation above the mean. If you add 34 and 34 together, you get 68. And so here we can start to visualize that empirical rule, which is kind of cool. Now, if we look below the row for standard deviation, we have this thing called percentile. Now, percentile just tells us how much of the sample or population scored below a certain value. So we can see that the mean cuts the distribution in half, and that's why it's at the 50th percentile. 50% of the sample or population falls below that value, and 50% falls above. Now, the cool thing about this also is that if we look a little bit below a standard deviation of 1, we see we have the 80th percentile, okay? Now, I want you to think for a second also. If you were to just look at these percentages up here, the 0.13, the 2.14, 13.59, and so on, if you were to add up these values, you'd also get the percentile, right? So if you think about 1 standard deviation above the mean and wanting to know what percentile that would be, you could add up 34.13 plus 34.13 plus 13.59 plus 2.14 plus 0.13, and what would you get? You get about 84. So that means that anyone who's 1 standard deviation above the mean is in the 84th percentile. It's kind of cool. And so that's how we can use percentile. We can start to see like what percent of a sample or population scored up to a certain point. Now that sounds a lot like cumulative frequency or cumulative percent, and that's exactly what it is. So when we were doing those frequency tables and we calculated cumulative percent, that was the percentile rank. And so that's what this line represents down here. And now we can kind of visualize what that looks like on a normal curve. Again, going back to 1 standard deviation above the mean, the percentile just tells us everyone that scored below that value, or the percentage of the sample that scored below that value. And to know the percentage of the sample that scored below a standard deviation of 1, we should just add up all the numbers that fall below it. And that tells us the percent that falls below that. So that's percentile, and that's how we use that. And what we're going to really focus on today is z-scores. Now that's the lowest bar or the lowest like line in this graph. And you'll notice that the z-scores have the same mean and same distance for standard deviation as the standard deviation line up at the top there. Now, that's because z-scores tell us the distance from the mean, okay? So the mean's always going to be 0 because the mean has no distance from itself. So the mean's always going to be 0 because the mean's 0 distance from itself. And then it's in units of standard deviation. So 1 standard deviation is the same as a z-score of 1, okay? Now, if the z-score is positive, like if a z-score is 1, 1.5, 1.75, 2, if it's a positive value, that means that it's above the mean. And if the z-score is negative, like -1, -2, so on, that means that the score is below the mean. So when you get a z-score, the first thing you should look at is the signage. If z is positive, you know that score is above the mean. And if z is negative, you know that score is below the mean. Next, the z-scores again are the same as standard deviation. So a z-score of 1 is the same thing as a standard deviation of 1. And you might be thinking like, why are we learning about z-scores if it's the same as standard deviation? And the reason why is because z-scores allow us to kind of convert distributions from one scale to another scale, right? Because z-scores are kind of standardized in a way. We can take a distribution and map it onto a z-score distribution. and then transform it into another scale. So I'll give you a more concrete example. Let's say that we have a distribution that's measured in inches and we want to convert it to feet, okay? We could take that distribution in inches and we could convert it to a z-score scale and then take that z-score scale and map it onto a distribution of feet instead. And so z-scores are really useful because they allow us to kind of make these conversions, and they also allow us to take into consideration multiple factors when creating like composite scores, which is pretty cool. Now, to calculate a z-score, we have this formula. And so this is the formula we're really going to work with in this chapter. The score, the z value, is equal to the individual score, that's x, minus the mean, divided by the standard deviation. So whenever you have to solve for z, you take an individual score and you subtract the mean from it, and then you divide it by the standard deviation. This tells you how far away that score is from the mean relative to how spread out scores are, or the standard deviation. And so let's get a little bit of practice here. Hypothetically, let's say we have a distribution with an average of 50 and a standard deviation of 5. There's 3 participants that we're going to focus on here. Participant 1 scored a 60, participant 2 scored 45, and participant 3 scored a 50. So first, on your own, I want you to draw the distribution and calculate the z-score for each participant. Again, you're going to solve for z here in that formula. Next, think about how much of the distribution is below participant 1, how much of the distribution is below participant 2, how much of the distribution is above or below participant 3, which I think will become more clear once you calculate that z-score. And then what percent of the distribution is between participants 2 and 3, or participants 1 and 3. Okay, again, here's the formula. And this is what I want you to get some practice on. Here's the normal curve that you can use with the z-scores, the standard deviation, and the percentile there. And try to kind of complete these activities on your own by calculating the z-score, and then use the percentile values here to determine how much of the distribution is below or above each of these participants. Okay, so if you have any questions with this activity, feel free to let me know, stop into my office hours, send me an email, but this will give you some really good practice working with z-scores here. Okay, there will be more practice activities in our module as well, but for now, this brings us to the end of our mini lecture video. All right, thanks everyone.